All right, everybody, welcome back again. Now we are still on solving right angle triangles. So this is still part of 7.3 and 7.4. The only difference now is that we're going to be solving for angles. In the previous video, we were solving for side lengths. So I just want to point out that you need to make sure you remember that the rules that we were following in the past two videos only are satisfied for right angle triangles. So previously we found side lengths. Now we're going to be finding angles. So the same SOHCAHTOA still applies. So our three trig ratios are still SOHCAHTOA, where sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Just like before, you still need to, for the given or for the angle theta, you still need to be able to apply how to label the hypotenuse, the opposite, and the adjacent. So now if you look at your calculator, again, doesn't matter what your calculator is. I want to make sure you remember that it cannot be in RAD. You want it to be in D, E, G, or D, whatever letter shows up on your calculator. So if it's not, you need to switch that. So in the previous video, you're clicking on these buttons where it said sine, cos, and tan. Now, if you look right above it, and it should be above it on your calculator, there's one that has a -1. So this is the tan inverse, the cos inverse, and the sine inverse. Those are the buttons that you're going to be using right now. So see if you can get that to work. Because it's in light blue, on this calculator, you would hit the second button, and then you would hit the sine button, and that would give you the sine -1. So try and see if you can get the values for sine inverse of this number, and then you can check back in a second. So hopefully you got these answers here, 13.59 and so on. Notice that when you do this, just so that you do know, when you take the inverse of something, what this gives you is it gives you an angle. So this would be 13.59 degrees. So all of those give you an answer in degrees. So let's try an example. We have to determine all the unknown angles and round to the nearest tenths. So I'm going to start with A here since A is labeled. So if this is our angle A, we must go through the same process. We need to label O, A, and H. So H, again, we should know from even back Pythagorean theorem. H is always the longest side across from the 90. O, if I put my finger on this corner, the only side length that my finger would not be touching is this one. So that's the O, and the remaining one is the A. So in this case, when you try to figure out which of the trig ratios, SOHCAHTOA, which one you're going to use, because we are given all three side lengths, it does not matter which one we pick. We have to pick angle A, and in this case, I'm going to say let's pick O and H since we haven't done a sine trig ratio yet. So we're going to do sine of our angle, which is A, and then we have O over H. This is 10 over 26. Now, if you recall back to simple equations where we had x plus 2 equals 4, if we're ever solving for x and we take this 2 to the other side, the opposite would be to subtract 2. Well, in this case, we're solving for an angle A. To solve for the angle A, it's stuck by this sine. To take sine to the other side, guess what the opposite is? You're right. It's sine inverse, so the sine -1. That's why we needed that button. So for this, to solve for the A, it's going to be A equals sine -1 of everything that's over there. And if you type that into your calculator and you do sine inverse, make sure you do sine inverse of the whole division, not just the top. You should get 22.6. And because when you take the sine inverse, it's a degree. So we then know that this angle here is 22.6 degrees. Okay, and we're asked for to round to the 10th, so that's perfect. The last thing that we need to do, because it asks us for all unknown angles, is to find this one. I'm going to label it X. So we could do a trig ratio again, but there's actually an easier way. If you recall back to like grade 7 and 8, we can state something about the inside angles inside the triangle. If we remember, all of the interior angles of a triangle should always add up to 180. So this would mean X plus 22.6 plus 90 should equal 180. And if you solve for this, you will get that X is 67.4 degrees. And so now you've solved for all of the unknown angles. So if we go to the next one, we're going to do the exact same thing. In this question, though, we're looking for angle C. So if we label what our angle C is, let's just call this one theta, so we're using the same symbol. If this is our theta, we have to label O, A, and H. So H is always across from the 90. O is always across from the angle that we're talking about, and A is always the one left over or the adjacent. So in this question, we are not given H. So if we look at the SOHCAHTOA, we are not given H. So we can't use anything with an H. That has an H. That has an H. So the only one left over would be to use tan. And if you look at tan, we have our O and we have our A. So this works perfect. So we have tan of our angle, which is theta, equals O, which is 7, over A, which is 12. We are trying to solve for that theta. To get theta by itself, we have to move tan to the other side. If we move tan to the other side, you have to do the opposite operation, and the opposite would be tan inverse of everything that's over there. And so if you type that into your calculator, you will get that theta is 30.3 degrees. Okay, and so if you don't get that, then make sure you put a star beside it so you can ask that question when you come to class. And there's one more example, but I'm going to let you try this one on your own. This one is to solve for angle D and round to the nearest tenths. So angle D is right here. So you're going to try and solve for that, and we'll check that tomorrow in class. Have a good one. Bye. Bye.